If you were born a few trillion years from now, you'd think the Milky Way was the entire universe, not because you'd be less intelligent, not because the technology would be worse, but because every other galaxy would just be gone. Not destroyed, just unreachable, invisible, beyond a horizon you could never cross. And here's the wild part. This isn't some theoretical far future problem. It's happening right now. Every second, thousands of galaxies are crossing a point of no return. They're not moving away from us in the traditional sense. The space between us is stretching faster than light can travel through it, which means we're seeing their last light, ancient photons that started their journey billions of years ago, but we'll never see them again. The universe isn't just getting bigger, it's getting emptier. And eventually, the night sky will go completely dark. Today, we're diving into what astronomers call the cosmic event horizon, the ultimate expiration date for everything we can ever know about the universe. And if you're into this kind of existential cosmic stuff, hitting like or subscribe genuinely helps the channel grow, because we might be living in the only era where the full story of the universe is still visible. The story starts in 1929 with Edwin Hubble. Not the telescope, the astronomer it's named after. Hubble was studying distant galaxies, measuring their light, when he noticed something weird. Almost every galaxy he looked at was redshifted. Their light was stretched toward the red end of the spectrum, which meant they were moving away from us. And the farther away a galaxy was, the faster it seemed to be receding. This was huge. It meant the universe wasn't static like everyone thought. It was expanding. And if you rewound that expansion backward, everything in the universe had to have been in the same place at some point, what we now call the Big Bang. For decades, astronomers assumed this expansion would eventually slow down. Like gravity from all the matter in the universe should be pulling everything back together, right? Maybe not enough to cause a big crunch, but at least enough to slow things down. Then 1998 happened. Two independent teams of astronomers were studying distant supernovae. These stellar explosions we can use as cosmic distance markers. They were trying to measure exactly how much the expansion was slowing. Except it wasn't slowing, it was speeding up. The expansion of the universe is accelerating, and that discovery won both teams the Nobel Prize because it completely upended our understanding of physics. Something was pushing the universe apart, something we couldn't see, couldn't detect directly, and had no good explanation for. They called it dark energy. Dark energy is honestly one of the most frustrating names in science because it makes it sound like some exotic substance floating around in space. It's not. Dark energy is better understood as a property of space itself. It's not in space. It's what space does. Think of it this way. When you have more space, you have more dark energy. And that extra dark energy creates even more space, which creates more dark energy. It's this runaway process that feeds itself. The more the universe expands, the faster it expands. Here's the thing that should kind of terrify you. Dark energy makes up about 68% of the total energy content of the universe. Matter, all the stars, planets, gas, and even dark matter, only accounts for about 32%. We live in a universe dominated by something that wants to rip everything apart. Right now, dark energy is still relatively weak on small scales. Gravity holds galaxies together. It holds galaxy clusters together. But on the largest scales, the space between galaxy clusters, dark energy wins. And it's only getting stronger. So what does this actually mean for what we can see? Let's talk about the cosmic event horizon. Most people know about black holes having event horizons, that point where gravity is so strong that nothing, not even light, can escape. The universe has one too, But instead of gravity trapping light, it's expansion pushing it away. There's a distance. Right now, it's about 16 billion light years away, where space is expanding so fast that light emitted from a galaxy will never reach us. Not in a trillion years, not in a Google years, never. That's the cosmic event horizon, and galaxies are crossing it constantly. In fact, we can already see galaxies that have crossed it. We're seeing their old light, photons that left billions of years ago when they were still within the reachable universe, but they've since crossed over. Any light they emit now will never reach us. From our perspective, they're frozen at the edge, fading, getting redder and dimmer until they just vanish entirely. They're effectively gone. Let me put some actual numbers on this to show you how insane this is. Right now, we can observe roughly 2 trillion galaxies in the observable universe. That's not an exaggeration. 2 trillion galaxies, each containing hundreds of billions of stars. But the observable universe is shrinking. In about 100 billion years, which sounds like forever, but in cosmic terms is just a few laps around the galactic center, most of those galaxies will have crossed the cosmic event horizon. Future astronomers will only be able to see a few thousand galaxies, maybe even less.
In a trillion years, the Milky Way and Andromeda, which will have merged into one giant galaxy by then, will be floating alone in an expanding bubble of darkness.
Every other galaxy will be so far away, so redshifted, that they'll be completely invisible. And in a few 100 trillion years, even the cosmic microwave background, the afterglow of the Big Bang itself, will be stretched into nothingness. Future civilizations won't see a universe full of galaxies. They won't see evidence of the Big Bang. They'll look up at the night sky and see nothing but darkness and the stars in their own galaxy. They'll have no idea the universe had a beginning, no idea it's expanding, no idea there were ever other galaxies out there. Their entire cosmology would be wrong, and they'd have absolutely no way to know it. Now here's where it gets even weirder. We like to think of the observable universe as this sphere around us, everything within a certain distance that light has had time to reach us from since the Big Bang. But that's not quite right anymore. Because of dark energy, the observable universe is actually shrinking over time, not in terms of the distance to the edge, but in terms of what we can interact with. There are galaxies we can see right now whose light is reaching us, but if we tried to send a signal back to them, that signal would never arrive. They've already crossed the cosmic event horizon for outgoing communication. We can receive their messages, but we can't reply. It's like getting letters from someone who's already moved away. You're reading their words, but they're gone. You can't write back. Just think about that for a second. There are entire galaxies full of potentially billions of civilizations that we might be able to observe, but we could never contact. Not because of the distance, not because of technology, but because the universe itself won't let us. The cosmic event horizon isn't just a limit on what we can see. It's a limit on what we can ever know, ever reach, ever communicate with. It's the ultimate boundary. So why does this matter? Like, why should we care about what happens trillions of years from now? Because we are living in a golden age of astronomy that will never come again. We exist in this narrow window of cosmic time where the evidence of the Big Bang is still visible, where we can see the cosmic microwave background, where we can observe distant galaxies and study the large-scale structure of the universe. We can see the full picture. Future civilizations won't have that luxury. The universe will have erased its own history. The clues will be gone. The night sky will be dark. And if they're not careful, they might never figure out where they came from. In a strange way, we're kind of the lucky ones. We're living at exactly the right moment in cosmic history to understand the universe's story from beginning to, well, not end, but dispersal. We're the last witnesses, and that puts this weird kind of responsibility on us, not in some grandiose save the universe way, but in the sense that the observations we make now, the data we collect, the images we capture, they're documenting something that will eventually become impossible to see. We're creating a record of a universe that's quietly disappearing. There's this concept in physics called the cosmological principle, the idea that the universe looks roughly the same no matter where you are or when you observe it. But dark energy breaks that. An observer in the early universe would see a very different cosmos than we do, and an observer trillions of years from now will see something completely different again. The universe isn't just expanding in space, it's expanding through time in a way that fundamentally changes what's knowable. And that's just deeply weird. We're used to thinking that if something is true, it's always true, that the laws of physics don't change, that the universe operates the same way everywhere. But the observable universe is time-dependent. What you can see, what you can measure, what you can prove, it all depends on when you exist. We're living in the brief era when the universe is old enough to have interesting structure, but young enough that we can still see most of it. A few trillion years from now, astronomers will look up and think they live in a small, lonely cosmos. They'll be wrong, but they'll have no way to prove it. We're the ones who get to see the truth. And that truth is almost unbelievably vast and strange and beautiful. The universe is quietly disappearing. Galaxies are slipping over the horizon, one by one. The night sky is slowly going dark, but we're here now, in the golden age, when the stars are still visible and the story is still told in the light that reaches us. So the next time you look up at the night sky, remember, you're seeing something that won't last forever. Not because stars die or galaxies collide, but because the fabric of space itself is pulling the universe apart faster than light can hold it together. We are the witnesses to a cosmic vanishing act, and we might be the only ones who ever get to see the full show. The universe is disappearing. But for now, for this brief, precious moment in cosmic time, it's still here. Still visible, still telling us its secrets. Keep looking up, because eventually there won't be anything left to see.